Okay, so we're done with one type of design patterns. Okay, remember there was creational. What's the other two? Behavioral. Yes, good. And the one we're going to start next this lecture? Structural. Very good. Very good. Okay. So creational, we said the problem is that I want to create objects in a certain way. So Singleton had the issue with I want to create one object, but one object only. Factory was to rid the client object from knowing a lot of details. You know how when you go like student S equals new student such and such, right? Imagine if there's like 15 parameters that you have to give in. It becomes a lot more difficult. Okay, so the factory design pattern, which uses the delegation form, which is one type of engine of design patterns. The other one is recursion. But anyway, what's I gonna say? Yeah, the factory design pattern. Its job is to help the client alleviate all these details. The factory is the one that deals with it and creates those objects just based on just a simple indication, like I want a new laptop, I want an old laptop, and so on. Okay, abstract factory. The difference between that and the fact, again, it's the same concept in general, as in we're removing a lot of details from the client, but the only difference, the main difference, is that I want to create a family of objects, and tend to be this family are objects not of the same type, but objects of different types. So if I want to have something that produces an object of type A, an object of type B, an object of type C, all right, this is probably, I need something, an abstract factory. Okay, if I have a situation where I'm producing A followed by A followed by, even if it was at the same exact time, I don't need an abstract factory, just a factory would be good enough. Okay, now here's a situation. Right? You got my client, okay, and one time I need to produce an object of type B, another type B, okay, so on. I'm producing B objects, okay, and I have a different factory for it. Okay, again, I reuse the factory design pattern. I still don't need the abstract design pattern, the abstract factory design pattern, because I'm not creating multiple objects of different types at the same time. Okay, so I call on factory A, keeps producing this one, and this one, and that one. I call on factory B, produce this one, and that one. Here at the top, I call on a particular type of abstract factory, and it produces more than one type at the same time. So like we saw in the animal world example, we had the herbivore, carnivore. Okay, so when you see in an exam a situation, obviously it will tell you I want to create something. Just the word create is a big hint that it's a creational design pattern. Okay, so right away we know it's a creational design pattern. But then you start to ask yourself, okay, when I'm producing, okay, these things that I'm producing, it could be a thing or things with an S. Is it of the same type or is it not of the same type? Okay, now remember the meal example that I gave in the last lecture? We said there's a French meal. Yes, they're all meals at the end, but the meals consist of an aggregate of different types of objects. Okay, one was dessert, one was the main dish, and one was the appetizer. Okay, so when I see this, when I see I'm going to create objects of different types, I start thinking to myself, I need the abstract factory design pattern. And I'm seeing that I'm creating. Now, I might actually need two different factories, each one of them creating a single type of object. In this case, we're still with the regular factory design pattern. Okay, one is producing oranges, one is producing apples, for example. All right, there's still two different things, and I will call upon each one of them when I actually need to. Okay, now, had I needed a cocktail, well, I thought it'd be a pretty good question in the exam, actually. Had I needed a cocktail, right, where I needed to produce an object of orange and an object of apples, then I would have needed, huh? Say what? Yeah, but what type of creational? Guys at home? Okay, so let me repeat this again, okay? Here you are, you're in a situation, you walk into a place, right? And, your type of request either give me an orange, give me an orange, give me an orange, or give me an apple, give me an apple, give me an apple. Okay. What you need in this case is two different factors: one producing oranges, one producing apples. Okay. But if one of your requests is to have a cocktail which requires both, then my design pattern is going to be exactly, it's going to be the abstract factory design pattern. Do not get confused, because you might get a question saying your requests are either oranges or apples. It's just two factories. I don't really need an abstract factory. Well, it could be still in the same design, okay, but two factors, meaning, okay, let me actually draw this. Here you got your client, here you got your client, still same design. One is with factory for oranges, one is for factory for apples, and this produces an apple object, this produces a orange object. Now, apple, there could be maybe different types of apples, Macintosh, Gala, or whatever. Oranges, same thing, navy, and I don't know what type of, huh? Abu Surra, I don't know what Abu Surra is. I know, I don't know what they are in English though. I know navy. That's the only one. Navy buttons on. I don't know. Type. Naval? I don't know. Okay. But did you get this point? Ralim? Okay. بغض النظر عن the type of oranges that okay, you got it, huh? Okay. So guys at home, do you get this? Can you either say or type something just to let me know that you're okay? I need you to write something so that I know you're following me. Anybody did not understand anything what I've just said when I was covering? Or did I say something? Yeah, okay. Okay, so now we're going to move on to a new chapter, structural design patterns. All right. Okay, so with this chapter, we're going to begin structural design pattern. And the point behind structural design pattern is that here's the kicker, huh? The problem is I have a structure that I need to be able to handle. Okay, so the structure is my problem. The structure is the job. Okay, in behavioral, is I created a design pattern to exhibit a behavior that I need, state dependent or so on. Okay, with creational, the problem is I want to create something under certain conditions. Okay, and again, I say this because in an exam, you're gonna get a question. It's not gonna say this is creational or a structure or a behavior. This is question number one that you have to answer in your mind. And then afterward, you ask yourself, which type of creational should I use? Which type of structure should I use? Okay. And the reason why the questions come like this in an exam, because the real world doesn't tell you this is going to be a behavior design pattern or structural design pattern and so on. Okay. So under the structural design pattern, we have four: facade. Okay, and just be sure that you pronounce it correctly. It's facade, not facade. Because facade, that's a completely different problem. All right. And then we have the decorated design pattern followed by the composite, and finally the adapted design pattern. I think we're probably going to go through two design patterns this lecture. Okay, so the first of which is pretty easy, it's pretty simple. It's the facade design pattern. And this facade design pattern plays into this thing that we finished off with the singleton design pattern. Matter of fact, the facade design pattern actually uses the single design pattern to have a facade, an interface, a representative for a package. Okay. Now, the whole point behind having a representative for a package is you're afraid of misuse of the details in the package. Okay. Could be misuse or could be abuse. Okay. So misuse could be harm that is unintentional. Abuse is harm that is intentional. And the other reason why we need the facade is because the client who may cause the misuse or the abuse probably doesn't really care about the details and would rather not have worried about it. Again, this is the same exact thing that I was talking about last lecture. When you go into the bank and you want to produce a credit card, in the real world, we actually end up knowing every single department in that bank when you really didn't need to know any single department in the bank. You just wish you would talk to one person and one person only who would say, You want a credit card? All right, I'll take care of it. Just give me this information and I'll go deal. All right. Subsystems actually work the same exact way. Okay. You come with a request. The request comes in the form of a function call. Okay. Sometimes it's just the function call that is enough. Sometimes the function call with some parameters that you give. Okay. So what's your ID? What's your GPA? What's your that? I'll go do it for you. I know my classes inside. I have intricate knowledge of the classes in my package. I know how they work, which one to talk to first, which one to talk to next. Okay, these are the certain ways you can deal with it. All right, you don't have the option to just go in yourself. Okay, and the client, despite being deprived of this freedom or flexibility, actually is probably very thankful, saying, "Thank you very much. Yes, here's my ID. Go ahead and produce my credit card for me. Thank you. I'll just sit here and drink some coffee." Okay, fine. Um, Another advantage of having a facade, as you can see in this example, is that if we have a lot of class from the outside, a lot of clients dealing with my classes inside. Now imagine I have to, with a pair of scissors, you bring in a pair of scissors, I'd have to go snip, okay, and cutting off all these different links. You see how there's a lot of links that I need to click. Now, if I want to reuse this, I have to go cut all of these links. Now, if I use the facade, everything sinks into the facade, okay? And these are just use relationships. So I can just really cut them off and get to reuse this easily if I wanted to. Now, let me just move out of here for a second. I want to move over there, share the white screen. Okay. Yeah. Yes. No, it's not going to be an abstract class. No, it's got nothing to do with being abstract. We're getting there. We're getting there. Okay. We haven't finished explaining for that. Okay. But here's the point. Okay. You have a class. Okay. A package. That's an example to the nth degree. The package is called square. Okay. It has a class called height. It has a class called width. Okay. Obviously the width is exactly the same as the height, but anyway, it has a variable here, x, and it's equal to 5. It has an x equals to 6. Okay. You have two clients. Client 1, you have another client 2. One of the things that this package offers is the ability to change the size of the square. Doesn't matter how much or how different you change the size of the square, still the height, the width is always going to be equal to the height. Otherwise, it's not really a square. Type. Imagine this scenario happens. Oh, actually, yeah, 5 and 5. Okay. This guy comes in and says, I want to change. So they begin with the width. This guy comes in, says, I want to change. They begin with the height. Two different objects. So there's nothing wrong here. So object number 1 says, well, I want to change the square to a 7. Okay. So here we go. We change this to a 7. All right. Client 1 comes to the height and says, I want to change that to a 9. Okay. All good. Actually, not so good so far. Okay. Now, this guy releases its hold on the height. This guy releases its hold on the width. Okay. And now this guy connects to the height because it's not really trying to abuse. It's just really just a case of misuse. While this guy access this one. So what happens? This one changes it to a 9. And this one goes ahead and changes to the 7. Okay. We have a race situation over here. Okay. And then this guy disconnects, says, thank you very much. This guy disconnects, says, thank you very much. And in the end, we're left with a square that is not even actually a square to begin with. Okay. So what we want to do is we want to stop all of this mayhem. Okay. We have the square, you have the height, you have the width. We want to have a facade so that every client who comes in, they have to come in through the facade. Okay. The facade knows that if I'm going to change the height and the width for client number 1, client number 2 has to wait until I'm done. Okay. This is one of the ways it stops any misuse or abuse to begin with. All right. So doesn't matter 9 or 7, it doesn't matter. Whoever comes first, whoever comes next will override. That's fine. But at the end of the day, at any point, that square It's always going to remain a square. So it went from a 5, okay, to a 7, to then later on to a 9. Okay, that's one thing. Now the other thing is obviously just a case of abuse. You know, you don't want C3 to come over here and just say, let me change this to 12, and intentionally not even attempting to change the width. It's just abuse. Okay, sabotaging the square. So you don't want that. Okay, you want those to have private access with just the facade. So only the facade can deal with it directly. Okay, let me just step out of here, go back to the slides. Okay. So the facade design pattern uses the, what type of form is this one? The delegation form. Okay, so instead of talking to the client immediately, which opens us up to misuse or abuse, we're going through a delegate. Okay, now this delegate, okay, this facade, we actually for in certain situation we want to have it to be singular. So the facade itself might even itself have a singleton design pattern on it, because if we have two, then the race situation we might be exposed to. Okay, one facade talking to the height before the width, and another facade is talking to the width before the height. So we end up with the same problem anyway. So sometimes you want to end up with just the one facade. Now, if the integrity of the data doesn't really matter, then you can actually have multiple facades. Okay. All right. So the sequence is very easy. So the client wants something from class C. It stops at the facade first, and then the facade does the work, returns any, if any, to the client. Now let's take a look at the code level. So at the code level, we have 3 classes. Okay. And we're going to have this something. This is subsystem 1, subsystem 2, subsystem 3, and 4. Each one just prints its name. I'm subsystem 1 method, I'm subsystem 2 method, I am subsystem 3 method, and I'm subsystem 4 method. Very easy. Okay, each one with its own function name, as you can see. All right, very simple so far. Now what we want to do is we want to create the facade. Okay, so this is what we had: 1, 2, 3, 4, and then now we're going to have the facade at the top over here. Okay, the facade is going to have access to each one of those, subsystem 1, 2, 3, 4. So as such, all right, the constructor creates the objects and the subsystems, and then obviously gives the facade access to it. So now the facade has access to all 4 subsystems inside. And now, assuming we have 2 legitimate ways to access the services that are offered by the 4 subsystems that are inside. The first of which is I have to execute the one in method 1 first. Okay, then 2 and 4. Okay, or I can just do, this is one legal approach, or another legal approach is I just do 2 and 3. Okay, I just do 2 and 3, assuming these are the legal ways I can do it. So I'm going to have 2 methods available to my client. So in other words, I'm going to have method A at the facade and method B, and then the clients are here, client 1 and client 2, and says, Mr. Client, you can either use method A or method B. Method A will give you 1, 2, 4. Method B will give you 2 and 3. And I can put, it doesn't hinder any flexibility. Okay, anything, if you actually want to use one subsystem at a time, if that's the legal way to use one of the things at a time, fine. Have method C. And in method C, just execute the 1 and 3. Okay, well, I want to do 1 twice, and then 3, 4, and then 2. Fine. I'm going to have a function called D. okay, where I do 1, 1, a 3, 4, and then a 2. Yeah, yeah, yeah. It will obviously tell you that these are the legal ways you can use it. All right. All right. So here comes the client. One time it accesses method A from the facade. Okay, so this is the method that belongs to the facade. Another one accesses method B. When it accesses method A, all right, it prints out, well, we've done 1, 2, and 4. If it accesses method B, it says we are doing 2 and 4. Okay, doing 3 on its own, maybe illegal. Doing 4, 4, 2, also illegal. Maybe these are the only 2 ways that are legal. Okay, I set in the facade what ways, the legal ways that I can use the classes that are inside.
So for the diagram, you have like facade to be pointing to the
Mm-hmm.
5 hours. You have 5 hours.
Yeah. Well, 4. So you got the
Yeah,
facade. Yeah. Yeah.
But how can I know that I'm what I mean that it will go to the 1, 2, and 4 in my diagram?
Yeah. No, in your diagram it won't show.
Yeah, it won't be understood.
No, it can't show in the diagram itself, but it will show in the code.
Yeah.
Okay. Now it can also show in the behavioral diagram if you say ask for a sequence diagram. So one way you can show it is that here's your facade, here's your client. Okay. So you can either get method A.
Then I can do the alternative solution.
Yeah, and then it goes, no, not necessarily alternative. It could just, this is A and this is B, or a different diagram showing B,
Yeah.
and the B was just a 2. Okay. That will actually show it. Show what? Yeah, you have total control. Okay. And again, it's not about making the client's life miserable. In fact, you're actually doing a favor for the client. Okay, because you save the client from having to know that 1 needs to happen before 2, before then 4. When all the client was says, just give me method A. Okay. Any questions, guys, at home? So that's the first design pattern for today, facade. Next one's a little bit more complicated. Guys at home, can you type something just to let me know that you're okay before I move on? Okay. So again, just غادة. All right. Okay, Osama. Okay. Okay. Oh, the constable. It's not working. Okay. So that stuff I already explained. I just want to move on to the next. There we go. All right. So the next design pattern we're going to look at is called the decorator design pattern. Okay. Now, the type of structure that is my problem that I want to handle in this design pattern is the linked list design pattern. It's my linked list design. Very easy. Okay. Now, here's the thing with the linked list. Okay. The client comes in, okay, gives us the linked list. So the linked list, that's my problem. Gonna give it to the design pattern classes. Okay. The design pattern classes themselves are not the actual linked list. Okay. So the design pattern is a solution. These are the solution classes, the classes that represent, and so should I say, the objects that represent the linked list is the actual problem. So the client comes in and says, here's my linked list. Now, what we want to also do, and this is also a theme that you'll find in all the design patterns, that we want to again alleviate the client from knowing a lot of details about what are the different types of objects that exist in the linked list, because there might be different types. Okay. Yes, they're all going to be inheriting from the same general type, but still there might be different subtypes, and we don't want to bother. Now, the other thing we don't want to bother the client with is how many objects that actually exist in that linked list. Okay. Basically, he has an axis. it's going to have an access to the very first object in the linked list, gives that first object to the design pattern and says, here's my linked list, kind of like a leech. Okay, you're holding a leech, right? And then the leech is holding the first, and the client is just giving the leech to the design pattern saying, deal with it. Now, it could be that there's one dog chained to another dog, to another dog, and another dog, and another dog, and so on. The client doesn't know, and frankly, they don't want to know. Okay. The other thing too, that's a benefit that you also see in a lot of these design patterns is the dynamism, okay, the flexibility. So, I can change the size of the linked list, okay, erase one, add a new one, okay, and then still through the same methods, get the client to give the linked list to my design pattern and says, well, I go ahead and handle this linked list for me. Now, when I say the word handle a linked list, mean the design pattern is going to go through each one of those objects one by one, execute something, whatever it is. Could be, for example, print your name. That's the job to do. Okay. Now we just don't know if this linked list has 15 students, 20 students, 14 students, one student dropped, another student added. We don't know. Okay. But when I say print student list, it should be able to handle this for me with dynamism. Okay. Okay. So in a linked list, there are two types of objects, one of which is called a decorator. Decorator is an object that is a non-leaf. In other words, it's not the one that could be a last one in the list. Okay, so in other words, it has something following it, or it has a substance. The substance is a leaf object, which means that there's nothing else that can come afterwards. Now, if there is something that is following afterwards, this is where this link is coming in, and now it's saying to the next object, you go ahead, do your work, and hence we're using the recursion form. Okay, so we keep delegating, but we keep every object keeps talking to the one next to. So now, after I talk to the first dog in the chain, and I say, okay, I'm gonna wash you or clean you. All right, the next job, that dog tells the next one in line, go ahead and do your work, and go ahead, Mr. For example, take your own shower, so on. All right. So we have substance, we have decorator, and this is where the word decorator comes, and really the real world comes from the situation where you have that party prank where you have the big birthday box and you unwrap it, and there's another smaller birthday box, and you unwrap it, and then at the end of the day, what's actually inside is very, very small, the substance. Okay, and it's kind of like a joke, but you're just removing layers, and each one of those layers following to the next layer is nothing but a linked list, another object in the linked list. Okay, so when I have this situation over here, this was my gift. Okay, and this was one wrapper, one wrapper, one wrapper, and one wrapper. Okay. All right. Now, one thing that I want to show you here is this decorator class is pointing to an abstract class that could either be another decorator or another, or just a substance. Now, what this is saying is, me as an object, I know there's something else that's coming after me. I don't know if there's something else. Oh, this is getting really annoying. I don't know if there's something else is a substance. In other words, going to be the last one, or is it another decorator where another object can follow after it? And frankly, I don't care. I know there's one that's going to be following me. All right. When you create the linked list, you decide if the one's following me is another decorator or if it is a substance object. Okay. So here you come. The client comes in. Okay, this is my linked list over here. A whole bunch of decorators until we get to the end where I have the substance. All right. Now, as you can see, the client says to the first dog or the first object, do your thing on your object, right? And after it does it, This object tells the next one to go ahead, do the same thing, go ahead and do the same thing, right? Each one is responsible for telling the object that is following it to go and execute that same function on it. Okay. All right. Some real example, for example, when the GUI, right, there's a rendering machine, it renders a whole bunch of components, not just the one component. I'm not sure if you actually did some GUI programming. So you get the J panel, the J button, right? And all of these are things that you do what the rendering machine do right after each other. So what you're giving it a whole list of objects to be rendered. And then it just keeps going through each one of them one after another. And then what you see at the end is something that looks like one piece, but it's actually not one piece. It was multiple pieces combined together in a linked list. And then the client says, render this for me to the rendering machine, gives it really the first one, it's just the pane, the J pane. Okay. And then the J pane tells the J scroller, and the J scroller tells the J button, and the J button tells the J screw, and so on and so forth. All right. Right. So the decorator, it has the scrollers, it has the borders, it knows that there's other things that are going to follow. The text area is probably the last one that I have. Okay, so I'm going to set that the text area is the last object in my list. So it's the substance class. Everything else is a type of decorator. Okay, in this class diagram, I had one type of decorator. In this diagram, I had two types of decorator. I could have had three types of decorator, four types of decorator that had subtypes and subtypes. I can do whatever I want. It's still the same idea. Same thing with substances. I could have had multiple types of, yes. So a decorator is an object that knows there's another object following me in the list. Now, what it does, it points to a component object. Okay, this line over here, it points to a component object because it doesn't know if this next object in line is another decorator, i.e. another one that requires another object to be following, or if it's a substance, i.e. a leaf node that doesn't have. And frankly, it doesn't care. Okay, all I know that is there's going to be somebody, is it another decorator or not? None of my business. Okay. The decorator is a design pattern in itself. Okay. Now you create a class diagram that's a static view, and then there's a dynamic view. Okay. All right. So you'll realize a lot of class diagrams actually end up looking quite similar. So this is why I do request that you actually write down the name of the design pattern in the exam so that I know it's not just a stroke of luck.
Yeah, well, I didn't actually get what are we adding here to this, like let's say I have this diagram.
Yeah.
How can you implement the decorator?
Yeah, we're getting to that. The implementation.
Yeah.
Every design pattern. Okay, let me set this as a theme for the rest of the design pattern. Every design pattern, you gotta look at it at the code level. Okay, because I know that just looking at diagrams won't make much sense. Okay, so just like with the facade, we looked at the code. In this one, the following one, the composite, the iterator, the adapter, every design pattern, you're gonna look at it at the code level. Okay, the code level really shows you the machinations. Okay, so in general, let me just take this out. I know you want to get to the code, but let me just stop here for a second. So in general, you're gonna end up with objects. Okay, those objects are represented by classes. Okay. Now note, this is class A, class B, class C, class D. This could have been object A, followed by object B, followed by object A again. Okay, objects are different than classes, followed by a C, followed by a D, followed by whatever, A, and so on. Okay, now the point is, all of these, oops, that didn't work out well. All of these need to be of type some parent. In other words, all of those over here are going to be of the same type. Okay, Now, the point is that the client thinks it's dealing with an object of type parent, and then polymorphism kicks in. Okay, one time it was an A, next time we remove it, it's a B, next time we remove it, it's another A, next time we remove it, it's another B, and so on and so forth. Okay, just keeps changing what's inside. Okay, but all of them, it thinks it's dealing with an object of type parent. Okay. When I look at my linked list, I decide what are the types of objects that exist. Those are going to be at the bottom over here. If I know there is a type of object, if I know there's a type of object that cannot have any objects following it, then I would designate that as a substance. Okay. If I do know there's one following it, then I would designate it as decorator. How do I designate? Okay, I designate simply by when I have my parent class at the top. Okay, if it's a type of decorator, then I will have just like the folder example in the quiz. It was going to point to another one in the list. Okay, so again, from the decorator's point of view object, it looks at the second one that is a parent. It doesn't really care what's inside, whether it's an A or B, or a substance, and the substance won't have something pointing to the top. Okay, all right. I could have had.
We can see what's happening, I think.
Oh, sorry, I forgot to do the switch
Can
thing.
only see the slides.
Yeah, I'm sorry. I wish it. So anyway, what I was saying, I'm just going to repeat this again. Okay, how do I designate the difference between the parent and sorry, the decorator and a substance? The substance is going to have a aggregation to another one on the list, and like I said, from the point of view of the decorator object, it thinks it's dealing with a parent object. Later on, through polymorphism, it's going to decide whether what's inside is a decorator or another substance. Okay, and also how do I designate a substance is I just simply don't actually have something pointing to the top of it. It stops. So when the function call actually comes down over here, it executes it and then it stops. Whereas over here, when the function call comes, it executes it, grabs the object that is following it, and says, now you do your part, which is the same exact function again. Yes.
So let's say I have a class gold and under we will have like orange.
Okay.
You want to execute the functionality of that class.
Yes.
If you did execute that's it, then it's a sub, right?
Yes. Okay. So
The class orange now is a sub.
yes.
That's it,
Right now, yes and no. Okay. Do you plan to have a linked list of orange objects?
No, if it's just in
Khalas, then that's it. Yeah.
Yeah.
Okay.
But
All right.
if it wants to call the next class, then it's a decorator.
Yes, exactly. So here's an example. Okay. I want to print the names of the people in the classroom. Okay. You and me. All right. Now, there could be many students, all right, online, whatever it is, right? But we know there's one professor. So makes sense that I would make the professor being the substance, put it at the end of that linked list, and make all my students being decorator objects. Very obvious, right?
But if we're talking about the same linked list, is the last value the tail? Is it a substance?
Yeah. Well, that's the whole point. Okay.
Yeah.
In the class diagram, because you're not having something afterwards, it cannot actually have. So if you have this, and this is your substance, because it doesn't actually have anything following it, then in an object perspective, the substance is going to be here. It's not going to have anything following it. Okay, right? And this comes back to the static modeling classes that we talked about, and I was very careful that I explained that there's a difference between thinking of classes and thinking of objects. Okay, because what happens is that when you see something like this, okay, you look at it and you think, oh, I'm going to have one scroller decorator object. I'm going to have one board. That's the wrong way of looking at this. You're looking at a class diagram and you're thinking objects. And that's what you're seeing is classes. You're not seeing objects. Okay, you're going to have multiple border decorator. I could have multiple scroll. I could have had multiple text views, but only one that would actually end a list.
Yeah.
Okay. Yeah. Okay. That's probably old stuff. Type. Let's take a look at the code example here. Okay. So here I am. I have my very general class at the top. It's called iComponent. Okay. This is an abstract class. So under it, I'm gonna have my decorators. Gonna have my substances. Okay. And it's saying every single class under me, please implement a function called operation. Operation, all it's going to do is just going to print some sort of a string. Okay, not really the interesting part here. Okay, we have a first decorator. Now this first decorator, let me just use this over here. No. There's a pointer. Okay. First thing you notice, because it's a decorator, it knows it's going to take. There's going to be something else in line. Okay, so this something else in line, I'm going to put it into the constructor of that decorator. Okay, so I'm going to give it an object C to follow that object A. And that object C is of type iComponent. In other words, it doesn't really know object C, what's going to be in it. Polymorphism is going to take care of that later on. Okay, so it could have been another object A, in other words, another decorator, or some sort of a substance which is going to come to towards the end. Okay, any object of type decorator A, when you go ahead and execute the operation, okay, all it does is it grabs the next component in line and asks it to, you go ahead, do your part, and then when you're done, come back to me, I'll do my part. Now, this is up to me. I could have flipped it, okay? I could have taken this line where it says, and listening to classic FM, put it before the one that says component.operation, which means I'm going to do my part first. And then after I'm done, you go ahead, do your part. Okay. And it's recursion. Why is this recursion? Because every object is going to go and ask the next one to go ahead, do your part, do your part, do your part. Now, it could have been that we're reaching the end first, and then we're going in reverse order, asking each object from the end to print first. Or I could have been doing my work as I'm going down to the end, and as I'm returning back, all I'm just returning is the control flow, nothing else. Okay. In this particular example, no, I decided to go to the next object first before I do my part. Okay. So this is decorator A. So far, this is what we have. We have the I component, and then I have decorator A. Okay. Next up, I have another component, another decorator. It's called decorator B. Okay. Oh, it also takes another one because it's the same exact thing as decorator A. It has to take something else. And again, it prints something. So it asks the next object in line to do something before it prints. And what it prints is the word to school before it moves on. Okay. So going back over here, I have a decorator B. Finally, I have my leaf node, which is, I happen to call it component, and its operation prints out I am walking. Notice a couple of things. First of all, it doesn't take anything in its constructor. That's one thing. It doesn't even have an access to another component in line, and it doesn't really care. Okay. And another thing you need to notice is that it doesn't have this line over here saying to whatever comes next, do your part. It just prints out the string, and that's it. Exactly. Okay. Now we have. So remember this. The substance or the leaf node. Okay. It prints out I am walking. Just remember this. Decorator B prints out to school. And decorator A and listening to FM, classic FM. Okay, just remember that as we go along. Okay. All right. Here we are. Here comes the client. So one thing that you'll see in the client is that it needs to, first of all, create the linked list to begin with. Okay. we're gonna give you a linked list to handle, this is the situation, then I gotta create the linked list to begin with. Okay, so we have a multiple linked list to be created. The first of which, after I create it, I obviously send it to my display function. Okay, you can see the word display over here. I just send it to my display function, and a display function says it grabs. Remember this, huh? The client thinks it's dealing with just the one object, and it's of type parent, and then the one object deals with the other ones coming next. Okay, so it really thinks it's just dealing with the one object. That's the beauty of it. والله كان فيها 50, كان فيها 10, كان فيها 15, 1. It's all the same. Okay, now in this particular situation, this line, I created a linked list that really contains one object and one object only, and that is a component. Okay, and what is this going to print? It's going to print I am walking. Okay, next up, and the second line, it prints, it goes, it's an A decorated one, so we have a decorated A pointing to B. And as we remember, again, I'm just going to remind you, it asks the next object in line to execute first before it does its own part. So what's it going to actually print first? It's going to print this followed by this. So it's going to print I am walking and listening to FM. Okay, and here's the dynamism: same objects but different outputs. Okay, in the second example, I have my component being given to a decorated B. So I have a B pointing to the component. Okay, what does B print? Okay, it preprints to school, but actually, just like decorated A, it asks the next object in line to print first before it does. So it's actually going to print I am walking. No, there's no decorated A in this one. Okay, so it's a different list. So this one was a linked list of C. This one was a linked list of A pointing to C. This one is a linked list of B pointing to C. Different linked list. Okay. So it says new. Okay. So it's gonna say I am walking. Exactly. Okay. Now let's switch it up a little bit. Okay. And example number 4. Okay. I got, this is my C decorated by an A, decorated by a B. So I got a B pointing to an A, pointing to a C. Okay. So that actually prints this first, this first, this first. Okay. So I am walking and listening to school. Okay. Whereas this last one is the opposite. I got a C inside of a B, inside of an A. So I got an A talking to a B, talking to a, yeah, very good. I'm walking to school and listening to FM. No, I'm walking. So I'm walking, yeah. And then B, yeah. So it's gonna C, then B, then A. So I am walking to school and listening to FM. Okay. And obviously I could have done whatever I want, right? I could have come over here that had A followed by an A, followed by a B, followed by a B. But if I have C, that's it. It stops. Okay. Yes. And all of them C was the tail. Okay. Now here's the kicker. Okay. In case I have a situation as such, going back over here, I have a decorator that may or may not have an object following it. So it could be a decorator or it could be a substance, right? There's only one small thing that I have to change in this class diagram. Okay. What do you expect this one thing is? Yeah? No, the aggregate still stays the same. Okay. Now I'm going to change something and I'm going to give you hints in the multiplicity. How would I change that? Guys at home? Just one small little addition that I'm going to do to this diagram over here to show that this decorator, it may or may not have something following it. No, star means it's going to be, star is a problem because star means 0 or more. Okay, so it could have been, this is my decorator, it could have had, you end up with a situation like that's no longer a linked list. Okay. Yes. Well, not again, Yasmin, not exactly 0 to start, because star again, huh? No, not one to many. I'm saying I might have it or may not have it. So all I'm trying to say is this decorated object may have something afterwards, or it may not. Exactly. So 0 to 1. I'm not going to push I'm just not going to be on the case today. All right. So that's going to be it for today's lecture. All right. Seeing the heads starting to drop off a little bit. Anyway, next lecture we have the composite. Composite is when we deal with a structure that is a tree. Okay, so if you thought a linked list was fun, tree's a lot more fun. Followed by, I can't remember, adapter. Oh, adapter is really, really fun. Okay, it's kind of like you iPhones and you like adapters and all right. Okay, so that's gonna be the topic for the next lectures, inshallah. All right, that's it for today. Bye, everyone. Anybody at home got any questions before I log off? Okay, so we agreed the quiz is on the next week. That we agreed on the 16th. Well, yeah, next month, so the 16th. Yeah, 16, and then the midterm the week after. No, the 25th. The 25th. Okay. All right. Bye, everyone.